Hello everyone, I welcome you to today's growth webinar. Thank you for joining in. My name is Amartya Bose and I'm a senior industry analyst at Frost & Sullivan's Healthcare and Life Sciences team. My expertise in the life sciences industry spans laboratory automation and clinical diagnostics sectors, and my educational background includes a master's degree in pharma with a specialization in pharmaceutics. Today, we are featuring an engaging topic as we aim to transform the laboratory automation journey from static workflows to adaptive intelligence. I am delighted to be joining featured speakers, Lucilla Martin, who is the growth expert and research analyst at Frost & Sullivan's Healthcare and Life Sciences team. And we have Dave Roy Chaudhary, who is the vice president of products at Infineon. I'd request them to introduce themselves. Lucilla and Dave, would you like to introduce yourselves for the audience, please?
Sure. Well, thanks, Amartya. Hi, everyone. I'm Lucila Martin. I am truly excited to be here with you today. As an analyst and a growth expert focused on the life sciences space, I've had the chance to explore how automation and adaptive intelligence are reshaping labs worldwide. So again, I'm excited to uncover how those technologies not only solve challenges, but also unlock the entire new growth opportunities. Deb, up to you.
Hi.
That's awesome. Thank you, Lucilla. My name is Deb. It's longer than that, as you'll see on my LinkedIn, but I go by Deb. And I'm working with Infineon right now, where we're building tools to help developers and builders make sense of the world, process data more efficiently. Specific to this topic, I've spent over 5 years of my 20 years career in life sciences, bio, tech, healthcare, and so on, specifically in software and data and analytics. And my contribution to this panel essentially is around how do we actualize insights as a service and contextualize that in the context of use cases that are obviously things that the laboratory automation entail. I mean, whatever the things are that the businesses that are going towards, how do we actually make it happen is what I'm really keen to explore.
Excellent. Thank you very much, Dave and Lucilla. So let's jump right in. So in this briefing, we will take a three-step approach to pivot, adapt, and grow with changing market demands. The idea in here is to trigger a chain of transformation. So to do that, we will set the stage by exploring the growth environment. This will aid our understanding of the why. Why are we doing this now? Next, we will deep dive into how to embrace change and overcome the challenges to thrive in the industry. And in the final section, we will unlock growth opportunities that are intended to maximize your growth potential. Given that next generation sequencing, mass spectrometry, and liquid biopsy technologies are moving towards augmented deployment, the adoption of automated liquid handling, sample management, and workflow automation systems, trajectory, technology, and tactics is pivotal to the transformative power of pan-omics, predictive, and preventive healthcare. With pre-developed workflows reducing the need for specialized programming knowledge, this ecosystem, valued at $4 billion, growing at a 7.2% CAGR from 2024 to 2030, underlines fragmentation changes in the product portfolio, particularly with no-code, low-code software and intelligent automation featuring sensing, visioning, mobility, artificial intelligence, and cloud computing entering the mix. Boosting efficiency, precision, and scalability, these systems are on the brink of a significant transition as the shift towards software continues to evolve the hardware-dependent design philosophy. So let's look at the key demand drivers across geography. Laboratory automation remains a powerful driver in North America owing to the changing landscape that involves blood-based biomarkers and genetic screening. This reflects in the region's steady demand for clinical tests, which are slated to cross 14 billion annually. A well-established network of key companies coupled with a widespread system-driven adoption trend, provides a fertile ground for tactical market expansion. Moreover, with an escalating shortage of laboratory professionals in the US and Canada, automation freeing up staff to focus on productivity and innovation stands as a force for good. The region's leadership also stems from a highly recurring specification-driven consumables revenue that contributes to global reach and scientific breakthroughs. For example, Avanto's acquisition of Germany-based Ritter expanded proprietary high-precision consumables offerings to the biopharma and healthcare end markets. So, while the lab automation sector is poised for fast expansion and consolidation, varying throughput demands a skill gap in technology alongside high costs, downtime, maintenance, workflow efficiency, and space constraints represent the barriers to growth. In Europe, the growth is driven by the adoption of workflow automation systems, which are deeply embedded in hospitals and diagnostic facilities in Germany, the United Kingdom, France, Italy, and Spain, with many facilities equipped with a maximum of 2 systems and up to 6 total laboratory automation lines. Aiding market expansion is the open automation approach, an important driver making the most of technological advancements. Example, Inpeco's FlexLab X is a total laboratory open automation system that connects to 50 instruments and 24 different manufacturers. The recent launch offers sleek graphical user interface and data analytics functionalities. So, what does this launch imply? It implies with improvements in robotics, data analytics, and communication standards, the generation of open automation systems improving accessibility and adaptability will grow the workflow automation sector beyond clinical chemistry and immunoassay to coagulation and glycated hemoglobin workflows. Moving forward, as laboratories look to scale sample management, the trajectory is shaped by perpetual innovation contributing to greater automation and efficiency. Example, Sysmex launched 3 modules with sample sorting, archiving, quality control, and cleaning materials functionalities to introduce greater efficiency. The 3 modules are connected to its flagship models in the hematology field. Eppendorf's growing SafeCode portfolio comprises cryogenic vials, conical tubes, plates, and related software. ICON's LabVIEW 360 aims to enable end-to-end sample tracking and aid transparency. On the other hand, the focus on improving regulatory compliance, especially for omics workflows and versatile automation, is boosting the demand for liquid handling systems. This product portfolio is characterized by fragmentation changes. For instance, Eppendorf released the next generation of automated liquid handlers to offer precision and accuracy with a user-friendly interface and customizable protocols. Given the rising bar for compliance with critical regulations, Eppendorf extended its software offering to support regulatory compliance in GXP environments. We also note the Digital Europe program $8.1 billion budget over 7 years has opened opportunities to test and develop interoperability solutions. Asia Pacific is outpacing the world in the market on the back of the total laboratory automation system adoption trend. The installation speed of Mindray MT8000 has exceeded 100 units since its launch in 2023, with more than 90% being installed in tertiary hospitals. This implies positive market response and strong installation performance of TLA solutions in China. Likewise, in India, TLA systems breaking into top-tier independent laboratories, hospitals, and public medical research universities underscores a bullish breakout. Noteworthy examples include Path Labs harnessing Inpeco's TLA solutions, All India Institute of Medical Sciences implementing Fiddle Ortho's TLA system, and Mindray providing a flexible total laboratory automation solution to Vadia Hospital. Overall, the lab automation sector in the region remains bullish thanks to the introduction of robotic technologies. For instance, ABB Robotics and Extalpi joined forces to engineer various automated workstations, including autonomous mobile robots for liquid handling. with companies like Agilent partnering with ABD alongside Beckman Coulter's engagement with Fuji Bio to develop, manufacture, and drive clinical adoption of neurodegenerative assays using scalable lab automation technologies, countries such as China and Japan are slated to push the robotic system adoption trend. The Middle East and Africa region projects significant upside opportunities with high value for discovery because of the genetic diversity prevailing in the human biosamples. Cold chain capabilities are expected to drive the next leg of growth. In this context, Azenta, which is one of the leaders in sample management technologies, and the B Medical Systems acquisition is noteworthy. B Medical is an established vaccine cold chain provider primarily serving fast-growing emerging markets, including the Middle East and Africa. While workflow automation is a relatively new trend, but with liquid handling finding its way into GXP environments and regulated laboratories, diagnostic lines are anticipated to experience substantial growth. Moreover, with companies like Methflow and Flow Robotics announcing a distribution partnership, automated liquid handling is a breakthrough trend. Saudi Arabia preparing to invest $65 billion in healthcare initiatives alongside the promise to improve private sector contribution to 65% from 40% by 2030 opens commercial opportunities for global companies. This implies that the potential to roll out large-scale automation technologies, especially in hospitals and primary health centers, will stem from the need to improve accessibility, efficiency, and transparency. With companies expanding their presence in Latin America, the high throughput sequencing market for workflows continues to be lucrative. Assisted by strategic partnerships, advancement underscores the growth potential of automated liquid handling systems in genomic workflows. Example, MGI partnered with OncoCliniCast to expand access to genomic tests and strengthen diagnostic capabilities in oncology in Brazil. Clinical diagnostic company DASA forming a strategic alliance with MGI to expand access to genomics in Brazil will positively impact the automated liquid handling sector by optimizing turnaround time, reducing overall cost, and increasing the efficiency of the genomic laboratories. In addition to liquid handling, following the success of NeumaLife middleware solutions, providing complete flexibility with simplified integration will witness demand as the marketplace looks to further streamline operations. To remain competitive while improving access globally, automation companies must invest in Latin America and strengthen their local presence. The increase in access tied to strategic partnerships is the way we see the revenues in the region growing. So, exploring growth involves adapting to challenges, and these challenges, when viewed from a micro to macro lens, are opportunities. Experiencing the benefits of lab automation without a large capital outlay has been a pressing challenge, with the prices of systems ranging from a few thousands to millions of dollars. System prices vary depending on specific needs and functionality, with speed, precision, adaptability governing the design philosophy. The patterns affecting price include reliability, accessibility, affordability, compliance, throughput, complexity, cost of consumables, accessories, or any spare parts which are involved. So the question is, how do we tackle the mounting pricing challenge? The recipe lies in the OEM partnering model. Unlike do-it-yourself solutions where financing is limited by the fixed costs associated with internal development, offering financing options makes automation more cost-effective. The agile methodologies minimize turnaround time and accelerate the production of functional prototypes so that each subsequent stage in an automation project improves and builds on what is already there. Now, once the design is optimized, the next step involves scaling. With substantial automation already existing in clinical chemistry and immunoassay workflows, tapping into the complexity of genomics and specialized workflows, including genome mapping, multiplex biomarker detection, single cell, and multiplex gene expression analysis, represents the next pillars for innovative success. Thanks to their potential to revolutionize various research areas. With many small and mid-sized companies and startups blooming, the hardware market is overcoming entry barriers to automation by establishing affordable processes. The sector is undoubtedly competitive. A way to tackle the price challenge here is to drive the shift from fixed to flexible automation using advancements in robotics. Good examples are Opentron's Hudson Robotics, Biomolecular Systems, Formuletrix, and Biocero, which are focused on developing low-cost, robotics-driven open automation and vendor-agnostic software solutions. Another important barrier impacting widespread system adoption and usage is interoperability. This includes the lack of standardized lab orders and lab reporting interfaces in the dirt of generally accepted standards that have minimal disruption to work and productivity, failing to ensure interoperability between new and existing systems creates fragmentation, which makes the process of integrating hardware and software a multifaceted challenge. Proliferating data silos, higher validation burdens, poor scalability, and reduced productivity impact digital transformation triggers such as remote designs, execution, and monitoring. Hence, labs equipped with legacy systems and established workflows often do not adopt to new automation principles due to data inconsistency costs. So now the question is, how do we overcome this challenge and aid the transformation of laboratories into decision engines? Before jumping into solutions, we need to recognize that there is a learning curve in developing coherent workflows to communicate between disparate systems and make workflows more intuitive. Now, to achieve interoperability, the standardization challenge should be adequately addressed. Leveraging an orchestrated integration model is one way to do it. Triggering accessibility to all operating systems and organizing sub-packages for hardware systems are ways to adapt to diverse workflows spanning research, pharmaceutical, and clinical diagnostic applications. So this interoperability piece of frugal innovation will not only enhance efficiency and accuracy, but also enable the user to focus on complex inquiries by reducing the burden of manual tasks. Furthermore, aiding agile data governance will lay the foundation for laboratories to function as decision engines. Amidst the top challenges faced in laboratories, automating regulatory compliance to build an adaptable framework can be viewed from a growth perspective by recognizing the shift towards intelligent laboratories. This shift aims to not only improve efficiency, but also engage in more complex roles rather than just routine reporting of figures and data. Tailored to meet the regulatory needs of laboratories, the system-driven adoption trend must be driven by software. Ingesting real-time data will not only equip systems with regulatory compliance features, but also support 24/7 remote diagnostics, AI-enhanced automation, and real-time monitoring. Additionally, a highly accessible user interface, login access control, and predictive intelligence can altogether establish a new standard in automation, particularly in the context of new science exploding, including CRISPR, large molecular development, CAR-T therapy, and blood-based neurology biomarkers. The critical role of geopolitical developments, including the implementation of tariffs and trade barriers, primarily between the US and China, is causing increased uncertainty in global markets. The scenario underscores strained international relations and divided global powers. The intersection of automation and geopolitical developments is likely to create a dynamic environment that pivots on adaptive strategies and robust policy responses. The critical importance of proactive governance and strategic foresight requires forging global alliances for better managing risks and leveraging the opportunities presented by geopolitical threats. This is important as the World Economic Forum estimates that automation to create 97 million jobs by 2025, and the OECD predicts half of the global workforce will require significant reskilling by 2030. If executed, sustained benefits could boost the global GDP by 6.5 trillion by 2030, translating to a global productivity growth of 0.8% to 1.4% annually. So what does this imply? It implies the displacement of a significant number of jobs, increasing use of automation, and investments pouring into upskilling the global workforce. So when summarizing the growth environment and the challenges, I think we all agree that disruption is coming, whether the industry wants it or not. And I believe everyone acknowledges that embracing technological advances in robotics and software is crucial to overcoming challenges. So now the question is, what is the return on investment? How do we measure and determine ROI for automation projects? And the follow-up question is, what is the focal point for future-proofing automation? So the return on investment from automation is the long-term savings from labor costs, fewer errors, and enhanced throughput. These typically outweigh initial investments. Compounding these financial benefits sets the stage for sustained profitability as the laboratory scales. A case in point is workflow automation systems, which bring high upfront costs, but their implementation enhances laboratory performance, has a relatively quick payback period, and reduces total hospital expenses in the long term. Now, to address the follow-up question, augmenting scalability while future-proofing automation relies on modularity, interoperability, and sustainability, requiring the development of innovative, eco-friendly laboratory automation systems. So now that we know that challenges are truly opportunities, let's deep dive into product and services-led growth opportunities and understand how these adaptive strategies can maximize your growth potential. For this, I'd like to hand over the session to Lucilla Martin, who will help us unlock the growth opportunities. Lucilla, over to you.
Well, thank you for all that insights and wide explanation of the market and the status quo of the labs, the trends that we are seeing nowadays, but also the challenges. So now let's go deeper into some opportunities. The first one, and I think this is something we all know, the evolution of software, but most specifically the software-driven automated liquid handling systems. Let's start in the beginning. I mean, historically, the significance of liquid handling to improve efficiency while saving some costs and drove the adoption of multi-channel and mechanical pipetting systems in labs, were in a way that it's really different nowadays. I mean, over the last 4 or 5 years, multiple acquisitions by some of the largest vendors in labs and in the lab ecosystem in general entail a sustained surplus for low-volume automated liquid handling systems. And few examples include Beckman Coulter, which is a Danaher company acquiring the acoustic liquid handling company, LabSite, for examples, or Waters investing in Andrew Alliance to enter the mid-range for robotic liquid handling systems. Also, an SPT LabTech acquiring Apricot Designs to advance automated liquid handling, and Hamilton, which bought Biofluidics to enable precise dispensing in the nano and picoliter range. So we are seeing a lot of changes, and with sensors and robotic systems delivering precise performance and process controls, software solutions designed to meet regulatory standards while maximizing efficiency. And those are critical for the proportional scaling of automation liquid handling systems. A few examples we can mention like Tican develop a suite of software features to develop compliant and audit-ready operations. Also, leveraging state-of-the-art security algorithms, the Echo 21 Compliance Manager is integral to the capability of Beckman Coulter's disruptive acoustic liquid handling technology. And more recently, reconing the enhanced feature set GXP software for regulatory compliance from Eppendorf. The solution unlocked continuous innovation, and SPT LabTech update this Firefly liquid handling software to also elevate usability and address compliance requirements. So in addition to compliance adherence, the development of software solutions for hardware is another decisive trend. For example, to serve lab personnel, yet to adopt automation, liquid handling paired with intuitive no-code software resulted in the development of cost-effective automation solutions. Sorry. Another recent example was Hamilton developing the smartness application interface software to empower laboratories with total controls over fluid dynamics across diverse applications. So streamline challenges such as data fragmentation, reproducibility, and compliance. The addition of software capabilities offer immediate synergies through reduced KEPs or OEPs, automated and connected workflows, and also accelerate breakthrough capabilities. As the software component records double-digit growth, as you were mentioning before, Amartya, versatile automation streamline complex workflow while also reducing downtime and elevating productivity, and it will overcome barriers to automation, including efficiency, precision, and also compliance. So combined with analytics and pre-developed workflows, an automated liquid handling system designed for impact at scale is a step forward in democratizing automation. And that leads us to the idea that software is the engine that transforms liquid handling in laboratories by integrating precision, compliance, and efficiency into a single automated solution. And while software has been a key to scaling automation in specific tasks like liquid handling, let's now take a broader step and explore how this transformation is expanding regionally, especially in the Asia-Pacific region, which is, well, a hot topic everywhere for each life sciences market or industry, where full laboratory automation is redefining the standard. So let's move to the second opportunity, anchoring back on our growth environment findings that, well, we were sharing previously. Those findings demonstrate that APAC outpacing the world by capitalizing on the total lab automation trend. I like to decode these growth opportunities into two parts. The first one is by taking a step back and adding to the context discussed in the growth environment slide. Because, well, globally, the top five players, we can say Beckman Coulter, Abbott, Becton Dickinson, Thermo Fisher Scientific, and also Mindray, control more than the 70% of the market share. And there are key players like Hidalortho, Inpeco, Siemens Healthineers, Roche, and also Copan. So widely adopted in clinical labs, the success of workflow automation stems from a range of system connectivity options and superior modularity. And what we see with those examples or companies' name is that the global market and the global companies, the global leaders are now putting a lot of effort to develop their solutions and to gain traction into the APAC market. So I mentioned all of global names, and there are a lot of local players too, but, well, they are controlling the 70% of the market share, which is crazy because it's a huge number. But, well, again, those lab automation solutions that are widely adopted in clinical laboratories, and the success of workflow automation that stem from a range of system connectivity options and superior modularity also allows configuration to be flexible, scalable layouts, and maximize workflow while keeping pace with future growth. So the trajectory in APAC is being shaped by companies, again, like Mindray, Roche, Abbott, and Inpeco, consistently expanding their layouts. When global markets are constrained by the slow pace of technological innovation, APAC, and especially some countries like China, is usually in a new era of intelligent workflow automation. A noteworthy example is China-based YHE ITLA Max, which integrates artificial intelligence, visual recognition, and total automation. Its launch core advantages include throughput of up to 1.2 thousand samples per hour, with a focus on achieving key milestones and solving practical issues such as enhancing workflows and optimizing performance. This newly launched system puts the region at the forefront of technological innovation. And now let's go to the second part of this growth opportunity, which is about our call to action, given that lab seeks a truly multidisciplinary approach to total lab automation. An adaptive growth strategy will be elevate the value proposition of TLA systems. And vendors are leveraging design software solutions to conduct a workflow analysis alongside data-driven simulations, and that can ensure that remote deployment of total lab automation solutions. So fast systems benefits such as throughput analysis, AI-powered visual insights, performance leads, fast-track emergency processing, biosafety protection, and also versatile compatibility are achievements that represent a starting point rather than an end state for customers who can now focus on automating smaller sites in the hub and spoke network, improve workflows at collection sites, and also reduce patient turnaround time. And with the future of labs promising a versatile landscape, stakeholders must or should reshape the role of total lab automation, forge into small and medium-sized labs, and adapt modular systems to new technologies quickly, safely, and also responsibly alongside humans. So in this context, the robotic approach has the potential to reshape workflow automation capabilities, with AI standing as a driving force for enhanced intelligence, responding to integrated environment, and also navigating autonomy by acquiring knowledge from past experiences. Mobile cobots are one of the most important examples here that may take charge of the entire sample logistics or aid while running in parallel mode during routine operations or easily handling simple tasks such as achieving process samples. So the final idea is that APAC is leading the way in total lab automation thanks to intelligent systems that combine AI, high potential capability, and also adaptability to new demands. So overall, automation doesn't end with hardware. It is also require connecting workflows, enabling remote access, storing data in the cloud, monitoring assets, and more. To make precision healthcare accessible to all, we need to decode the journey from data to decisions, and embracing the insight as a service model can shift the value of labs. So it's no longer just about speed or test accuracy, but about transforming into a data-driven service organization. So now I think it's important to question or to think on, as we traverse the last mile in the digital transformation journey, how do we provide a cohesive digital experience within a dynamic architecture? And that's why we have here Deb, an expert and the most accurate person to talk about that. So Deb, can you share some insights on how can stakeholder harness or adapt to an insight as a service model, given that industry use cases remain limited?
Yeah. Thanks for that perfect segue, Lucilla. I will reiterate certain aspects of what you mentioned just to set the context. But I want to say, since you mentioned last mile, it's more like the last few miles of a marathon that we've been running for decades, basically. Because if you look at the entire thing, it's not come about as a light switch. It's not like this discovery that we just discovered. I mean, the history of robotics, AI, intelligent process automation, data processing, and computer science as a whole is a better part of at least 3-4 decades of work of lots. So we certainly stand on a shoulder of giants, right? And we are trying to learn from past mistakes and trying to figure out things. So having said that, now when we think about the things that you mentioned, we desire to have this transformation which will make it decision factories, right? Laboratories as decision factories is a term that you used. and we're talking about insights as a service to power those decisions. So I think of it like an onion, and we want to just like peel some of the layers and talk about what exactly is the current state and what are the different layers of this system, and how we can, let's say, as ourselves decide to partake in this growth transformation, if you will. So maybe we can just start with this aspect of 2 use cases that we talked about of sequencing workflows and liquid handling workflows, because we talked about genomics a little bit, we talked about liquid handling a little bit, and then we talked about total laboratory automation, which includes these 2 things as well. I believe the insights that we are expecting of this falls in the categories, as you pointed out, of precision in handling, reduction of human errors, providing reliable insights. And at that level, there is an aspect of trust, consistency, and things like that. There is obviously also operational efficiency, which has to be with the speed with which you can accelerate your research cycles. At the end of the day, for any business, it's really about time and money. Can you save time? Can you make me more money? And then in between that, you have to deliver certain outcomes to your users or customers or consumers or patients, whatever have you, to deliver those outcomes, right? And then there are the complicated aspects, which makes this last few miles of a marathon running already kind of weary and tired, if you will, really difficult, because there's significant complexity. When you're trying to scale this with all of these different systems coming together, the insights that you expect, how does it scale, how does it work remotely, how does it work in smaller scope, and how does it work in broader scope? These are just certain things to think about. Now, as we get down into the specific nuances of this, let's kind of take the liquid handling piece and zoom in. Let's say we want to get optimized pipetting protocols, right? We want to get AI adjusted speed of pipetting, improving reproducibility by certain percentage points. Let's say we also want to, because we are using robots and we are using sensors, we want to know when those things break, why they break, before they break. We want to predictively maintain those systems, and we need to know when they go wrong. We need to be alerted of this. And overall, we want to think about the reagents or the chemicals that are being used in this, right? You want to reduce waste, you want to reduce over dispensing and things like that. So let's say in the liquid handling piece, these are 3 insights that we are looking for. Now, the question then becomes, what are the systems that we are getting data from? And you've mentioned a ton of different companies and acquisitions and software. Obviously, I don't know all of them. I know the big ones. But if you think about it, we are looking at the robotic workstation sending you data, sensor sending you data. You want to monitor lab conditions, humidity, temperature, which will affect liquid handling and things like that. And you will have specific maybe devices which will measure absorbance or fluorescence. Sorry about that pronunciation there, but these kind of things are all inputs if you think about it, right? Now, one of the things that you would get when you get this generated data of the speed and error rates of pipetting, or the results of when you run an experiment, what does this result yield, and your temperature conditions, there is already in that data certain things to know about. One is that if you're buying data from buying equipment and sensors from different vendors, you might get those data in different precisions and measures. You can think of like temperature, right? When we are in North America, we talk in Fahrenheit, but in the rest of the world, we might be talking in centigrade. So there are various things, and when you look at resolution of that data and measures, there are metrics, there are measures. So already in that data, you see some complexity, and these systems also talk in different protocols. Right. So now what you're trying to do is, in order to get this data from these sources, to get these insights, what do you think are the challenges? If you think about it, what are the challenges? The challenges could be integrating these different systems. The challenges could be ensuring that this data is high quality, high precision, harmonizing them, making sure that when you're reading data from different systems and you look at it as a record, and you got tons and tons of them because they're high volume, especially when you go into the gene sequencing aspect of it, hundreds of gigabytes or if not more, right? How do you ensure that you're trusting that data, right? And then how do you ensure that the temperature sensitivity, I mean, it's not in our control in some sense. Like someone could just open a door and that would change, humidity, temperature, and things like that. And that might affect inadvertently. Now, I know that obviously these specialized equipments will have many, many barriers for preserving the state, but how do you make sure that these rare edge scenarios are not something that fall through the cracks, right? Because then you have a false positive or a false negative, right? So that's really the lay of the land when it comes to laboratory automation of the challenges. And if you think about the levels of abstraction would be a good way to consider. All of the hardware that you're using, the robotic sensors and devices from different vendors are here. Now, they may be made by different manufacturers and they would have certain idiosyncrasies and oddities in their data, which you need to deal with. And therefore, you need to think about integration at that level of abstraction. Then you go a level of abstraction higher, and now you're talking about querying this data and processing it and applying AI-based, let's say, inferences, right? And processing this to get some insights out of it, which includes AI inferences, which can be consumed by the level of abstraction higher, which is the interfaces where the lab technician or the scientist or the researcher is actually making use of this data. So if you go from the top down, top of that pyramid down, the user needs to, in a reasonably effective manner, at a reasonable rate, get an understanding of what is it that they're seeing, and basically get to this what to so what to now what, right? So you want to see what it is, and you want to then be able to rationalize why is it that you're seeing, what does this imply, and therefore what is it that you're supposed to do, which is the decision. And then when you automate that, that's essentially automation, right? So that's what you're trying to do. And therefore, at the interface level, as well as the level of when you're analyzing this data and calling out these AI systems, every space you think about the user's experience or the system's experience and the integrations needed as it impacts software integration, as it impacts data integration. And all of these things are, they add little by little more and more complexity. So think like now you're running this marathon, but there is little by little weight added to you on a backpack. And your race is becoming harder because one of the things is when data moves from system to system to system, it actually adds to its footprint, right? You're storing it in a system, you're sending it via network, and you're running transformations on top of it. All of these are actually costly affair, and therefore the margin for error is pretty slim. And there needs to be like effective training, as was pointed out earlier, and planning and things like that goes into that. Also to justify the ROI, because cost was one of the concerns that were mentioned in the earlier slide, that these things can get very expensive very quickly. And so you want to be able to work with the different players in the ecosystem in such a manner that you're cognizant and always actively thinking about what is the implication to the data, what is the implication to the systems that needs to talk to each other, and what is the implication to the user and the interfaces that the user will consume. Now, thinking about another angle of this, if you think about the genomics and the proteomics research, right? There, the insights maybe that you're looking for is identifying biomarkers, right? So you want, I mean, Amartya mentioned something around cancer research. So you want to know specific mutations of novel biomarkers, and based on this data, you want to accelerate, let's say, drug discovery. And that's obviously very, very big, high-level statement, but you want to make it faster. You want to then have some kind of optimization in your workflow at a slightly lower level, which may recommend optimized sequencing protocols, right? You may want to flag low quality samples, right? Some of these things are actually, working on files, let's say, which are hundreds of gigabytes that I already mentioned. And if you're sequencing genomes, whole genome sequencing works on very large data. And by the way, it's used in other domains, those patterns as well, right? So the volume of data that you have to process, the interoperability, the analysis, and things like insights, people just expect it to be real time. Like you never want to work on stale data, right? You want to work on data that is fresh, data that has been processed with all of the new data points that you've captured in your recent experimentation or recent trials and tests that you're doing, right? These are all sort of add on to the complexity of the challenges that we need to solve here. To go back to this again, the same things that you will find here is like the need to standardize and harmonize your data. Make sure that irrespective of whatever vendors you're putting together, they may be sending you different file formats, different protocols of data, and so on. But we need to be able to unify them in a sense, or integrate them in a sense. And then obviously all of this has to happen in a compliant manner with all of these data privacy guidelines and things like that, right? It's one of those things that kind of gets ignored a little bit, or is a little bit of an afterthought in data, is to be proactive about the security, the access control, the regulatory stuff. And for the user at the top of the pyramid that I was referencing, it's all about training the user, because not a lot of times you would be giving them, when it comes to software and robotics and automation, something that is truly intuitive. Like, I'm used to working in a certain way. Now you're showing me a different screen, a different interface. How do I make sure that the core insights, or the core numbers, or the metrics that I'm looking at looks so familiar and it's so easy to spot, right? That I can truly get the value of this automated insights that you generated. Because if I spend half an hour sitting to parse through that, then I might have as well do it on a piece of pen and paper. It didn't really save me the time, right? Sounds pretty mundane or simple, but you'd be surprised how much you actually see this in the real workspace, right? Now, when you think about like the automated diagnostics and total lab automation, which was the final thing that you were talking about, again, the patterns of challenges are the same. It's about system interoperability. It's about data security. It's about making sure that the data is consistent and harmonized. And when you think about these systems, it's about how do you ensure that you have, it's very hard to have a single control plane for all of this, right? But it's just a matter of like, do you have a single view that gives you administrative control if you're looking at all of this data at that level? And does it correlate with the levels below it, right? And there, you're probably looking at something like, again, diagnostic accuracy, bottleneck identification for workflows where you figure out delays and so on. So the way I would say to make it actionable, how you must approach it essentially with this, other than finding vendors and partners who would help you with this kind of transformation thing, the idea would be to first acknowledge that this software, robotic automation, and AI-driven stuff is normative. It already is, right? Like, so eventually we are looking at a world that eventually, when we finish this marathon before we begin the next one, let's say, we will have a digital representation, or let's call it a digital twin, to use a buzzword, of the entire laboratory and various components in it, right? So in order to do that, you need to understand how that device itself works. So a core component of training is to understand your own workflow, how you as a human use the system, right? Because that's what is getting partially automated. And so if you have to like monitor, and you are able to do higher dimension research because some of these work has been automated, the main point is really what repeatable workflows which are error prone has been automated. And if you really know that well, you'd be able to spot the errors in the automated workflow, because the automation will not be perfect, right? Any machine learning AI data scenario takes a while to learn and stuff like that. So you need to be very, very well versed with the workflow as it appears in the analog world, let's say. And then the other part would be to essentially understand very deeply, what does your data look like, right? What are the measures in your data? And some of this stuff is simple, like your temperature, humidity, and other stuff, which we all understand, I suppose, to a certain degree anyway. And then other parts are data that is specific to the genomic sequences, specific to the laboratory pipetting flows and stuff like that. So you understand the data, you understand the system, and you understand your workflow, right? then it becomes a thing of like, how do you consume this new world where there is a bunch of automation that does the things that some of the processes that were manual, which are now applying AI models and stuff like that. And for the end user, for the technician, for the researcher and so on, it's pretty much always along the lines of in each level, what are the anomalies, if any? Because you just need to be trained for the edge cases and the anomalies, and when things don't work. When things are working, everything is good. Like you just like go and enjoy a cup of coffee and keep doing the work, right? That's really the pattern of how I think of learning. And in terms of like software implementation, right, you may want to think about vendor neutral solutions, as I'd call it, which means that you may want to look at different software providers who have open source projects, who are vendors that work across the board with different systems and so on. Because even if you had a system by 4 different vendors which are proprietary, if there's a layer that could aggregate that data and harmonize it that was neutral, now you all of a sudden have flexibility, is a term that you use, right? To then analyze your data the way you need it and get new insights, because a lot of this process also is experimentation in the context of data. Not a lot of times you would see the data and know that this is what you want to do. Sometimes it would be like you are ad hoc querying, you see some pattern, you validate certain things. There's active experimentation in that space as well. And so if you are confined to whatever a locked-in vendor would only offer you, you could only do the things that they will enable you to do. And therefore, thinking about certain vendor neutral solutions that enable this system integration, this data integration, and gives you interfaces to play with it, just the same way as we're playing with chemicals and genomics to find out cures for diseases, the same model sort of works with the data. And making it as a service is really just saying that you make it easy for people to access with the right access rules, that they can come in, they can see pretty quickly what it is that they're looking for. It's updated, it's fresh, and they can make the decisions that they need to, right? So that's basically a gist of how it is. I'm happy to answer any questions. I tried to keep it as simple in language because there's just so many of specific terminology in this, right? Hopefully this makes sense. If there are any questions, I'm happy to respond to them, and I'll pass it to you, Amartya.
Perfect. Thank you very much, Dave. Thank you for your context-aware insights and also context-aware problem solving. So as we conclude our webinar today, we'd like to learn more about where you are placed in this laboratory automation journey. Feel free to reach out to us for a growth dialogue, and we thank you for your participation. I wish everyone a fantastic year ahead.